Hello, this is Jim McKeeth, Lead Developer Evangelist for Embarcadero Technologies, and welcome to this C++ Developer Skill Sprint for February 11th, 2016 on using effects, animations, and transitions on your FireMonkey components. To download the samples and for more information and links from this presentation, visit embt.co/sprint-effects. This skill sprint works across all platforms and all languages, so if you're watching this, you can take advantage of what I'm showing you right away. So here's a quick agenda we're going to cover. We actually have quite a bit we're going to talk about, and I think it's quite interesting and I believe also quite useful. But before I get into all the technical details, let's talk about a little about why you would want to do this. What we're going to look at is ways you can give your user interface more life, to make it more interactive and to make it more intuitive to your users. So basically the idea is, sure, you can make it crazy, fancy, and exciting, but what we want to do is we want to make the user interface engaging and make it apparent to the users through animation and effects for how the user interface works. Now, I'm not going to get into all the details about how to do that. If you check out Google's material design documentation, that has some good information on there about how to use animation and such to show the affordances that the user interface provides. So lots of cool stuff, great information if you want to get into good UI design, but we're going to show you the technical aspect of how you can do that so that you can take advantage of the user interface design guidelines that you're aware of. So FireMonkey Basics, this is just the basics of it, but anything can be nested. You can put an image inside of a button and then you have a image button. So everything can be nested. Also in FireMonkey, most numeric properties are single or floating point numbers, and they're animatable. Okay, so that means the position, which is an XY coordinate, is floating point numbers. So it's not just 1, 2, 3. It can be 1, 1.1, 1.2, etc. And it's animatable, so you can use animations in order to change that. We'll talk about those in a second. Also, if you want to get the image behind a layout. So let's say you've put buttons and controls on a layout and you want to get a screenshot of that. You just call the make screenshot method, and that gives you back a bitmap of what it currently looks like, which we'll take advantage of. So that can be really useful. So animations, mentioned this previously, but animations give you the ability to modify the value of property over time, which is referred to as duration. These are really flexible. There's lots of different animations you can use. Most of the time, I find myself using the float animation, which is what you use to change a floating point value. But some of the other animations that are available there can change, for example, rectangles, colors, the color key animation, float key animation, and T-path animation change through a list of values, where the other ones change from a start point to an end point. The one exception to that is the bitmap list animation, and that one is like for a film strip, really, almost, where you give it a series of bitmaps and it just animates through those bitmaps. So it's like a film strip. And then the other ones, like I said, they change from a start value to an end value. You have events of on process and on finish. So on process occurs while it's processing, and then on finish occurs when it finishes. Now, you specify a duration and then you start it and it runs, and it uses threading. And because of the nuances of the system architecture, if you have two animations, and let's say you're moving controls around on the screen, they won't necessarily stay synchronized. Okay, and that's because the different threads get priority at different times and stuff like that, and it could introduce slight discrepancies in there. So if you do need to have two controls remain synchronized in the animation, you want to use a single animation control, and then on the on process, set the values that you want to animate on both of those. Okay, hopefully that makes sense. If you don't want to use the animate components, which is what I'll show you, you can also use the animate methods, which I'll show you an example of that as well. Anyway, this is a really powerful way to change the value of something over time. And it does a really smooth job. Everything's really smooth. and you don't have to write hardly any code to do it at all. Most of it you can do with no code. Occasionally you'll do a little bit of code. So a very, very powerful way to, like I said, change the value of something over time. And smoothly as well. Now, one thing when you get into animation, you're going to talk about interpolation, which is a really I guess you could say it's a strange sounding word. Basically what it means is it determines how the rate of the value changes over time. So linear is the default, and that's just where it constantly changes. So it starts at 0, and then 1 second later it's a 1, 1 second later it's a 2, 1 second later it's a 3, 1 second later it's a 4. That's a very slow linear interpolation. But some of the other interpolations, like a quadratic, start out slow and then get faster over time. Bounce, for example, actually it's like a ball bouncing. And so you can if you use bounce on a control, the control will look like a ball. It'll go up and down, up and down, up and down, or side to side, side to side. So that's kind of an interesting one, and it'll continue to get more or less as it goes. One note, though, is you also have animation type, and this controls how the interpolation is applied. So sometimes in other animation systems I've seen, it talks about easing in versus easing out, or easing both, and that's what the animation type does. So if you use quadratic, so quadratic starts out slow and then gets faster, and then use in out, then it will start out slow, get faster, and then slow back down again. So we'll have the nice gradual change. Some of the other ones, like for example, quadric or cubic or quintic are a more extreme version of quadratic. And so they'll start out slow and then get really, really fast and then get really slow again. If you take out that link there that you see at the top, that explains all the interpolation types in more detail. Okay, so effects. If there's over 40 GPU powered effects, and that's not including the transition effects, which we'll talk about later, that are available to you. They're built using shader filters. This means they take advantage of the GPUs. They use the shader language of the GPU to really be very powerful and very fast. The effects have optional triggers that you can use so that they can be applied automatically. So that means you can put an effect on a control and then have a trigger for like when the mouse is over the control or when the checkbox is checked or whatever to enable that effect. And so then you can add a glow effect to a control very easily. And it can be very flexible. You can do whatever you want to with it. So very cool. You can apply it to both images and controls, which is kind of interesting. So some of the examples we originally shipped showed it applying to images, but today I'm going to show you how to apply it to controls as well. So transition effects are specific types of effects that change the parent image or control into the target image. Okay, so you have a progress property that represents the percentage, how much has been applied over time. And then you can animate that progress property in order to animate the transition effect. So to have the animation effect, like for example, to fade in and out between things, you can use animation for that. Now, the transition effects transition either a control or an image into an image. Okay, it always takes an image as the target. So if you're wanting to transition from one layout to a different layout, what you would do is use make screenshot of the target layout in order to get a bitmap back to set as the target of the transition, which I'll show you in the demonstration. So now let's do some demonstrations. I've got 4 different samples I'm going to show you. Each one highlights something different. First one we're going to start out here is this animation sample. I'll run this here. Now this has animations attached to these different controls. So these controls here, when I check them, it activates the animation. So hopefully you noticed that it starts out slow and got really fast and then slowed back down again. So there we go, same thing, same behavior there. That's because it has in and out on the animation type, and then the interpolation, I believe, is quintic, which is the quadratic with the multiplier on it. Vertical, on the other hand, is going to use linear. So watch, it's just going to go the same speed all the way up and down. Okay, so they both take the same amount of time, 2 seconds, but the interpolation is different on those. And then scale, this one's going to scale when I move the mouse over it. And it has two on it. It has one for the X and one for the Y because the scales are separately. So you could have it scaled differently if you wanted to. Now over here, when I move this to a color and then click, or I guess just mouse over this, it will change that color. And another one on it, when I click on the rectangle rotates 90 degrees because that's cool. All right, let's get. There goes a. Anyway, so there you go. All right, so let's take a look at the code on this. Oh, wait, one more. I forgot. So here, this monkey is from a SVG. Wikimedia got this SVG of a monkey. And if you open it up, and I'll show you what the code looks like. So this is a path, a T-path in here, and it draws based on the paths we give you. And then this guy here has a path animation on him, that little rectangle. And so what it does is it follows the paths. And so they both have the same paths. So this one draws it, this one follows it. Which I think looks really, really cool. Okay. So now let's look at the code here. So there's not a lot of code because most of this is done through adding the components at the design time. So the horizontal checkbox has a float animation on it. The float animation is attached to position.x. So position contains X and Y. So you have to specify that it's X specifically. Duration is 2 seconds. The interpolation is quintic. Animation type in and out. Whereas you notice this one has a float animation. Right here, this guy. Animation is just animation type's in, but it's linear, so it really doesn't make any difference. This only applies if it's a non-linear interpolation. Okay, and then the stop value. So it starts at 0, goes to 500. Triggers when is checked as true, does inverse when it's unchecked. Now, a couple notes here. You can set start from current to true, and what that'll do is it'll start from whatever currently the value is at. If for some reason your checkbox may be in a state besides 0 or 100, like let's say someone unchecks it as it's halfway across the screen, then what would happen is if you set start from current is true, then it would change start value to whatever it currently is. Now, in this case where I have it looping, or an inverse trigger, what'll happen is this will get changed to 200, and then when I inverse it, it will go from 500 to 200. So it changes that value. So you just gotta keep that in mind, that if you do set start from current, it changes the start value. All right, and then I showed you the difference here with this one. This one goes 40 to 440 because it goes down, and it does it, is checked, so it's the same. The scale on the button here he is, button 1. It has on scale X and scale Y, trigger, mouse over, true and false. Okay, now over here on my color panel, what I've done here is actually used live bindings. So first of all, your animations don't usually show up in here for live bindings. And so if you right click on it though, and say bind visually, you see it gets added to there. It doesn't have any properties, but you can click these ellipses and we'll say stop value and add it. And now we can now live bind this. So I'm going to go ahead and remove this one. So what I'm doing here is the color panel's color property is live bound to the color animation's stop value. So that means the value that this gets animated to, the color animation gets animated to, is going to always be whatever color I just selected here. All right, and so this one says start from current, so that means it'll always change the start value to whatever currently this rectangle is, which should be what it stopped at last time. And that's it. Yeah, duration. I guess I can make the duration a little longer so you can see it better, but you all saw what it did. And it triggers on mouse over. Now, I find that typically an inverse doesn't work when you use start from current because of the fact it changes that start value. But there may be a situation when that's exactly what you want it to do. So that's an option for you. code. Oh, there's code on the click event for this guy here. And so what I'm doing here is I'm using the FMX Animator Animate Float. So this is the Animate method that you can use. And you just tell it the name of the object you want to animate, the property you want to animate, the stop value, and the duration. You can also overload this, or not overload it, but it has null procedures or optional parameters that you can specify interpolation and animation type. So I've always set the rotation angle back to 0. Now it's rotating 90 degrees. 90 degrees and 0, because it's a square, look exactly the same. So it rotates it to 90 and then jumps back to 0 again, so that it looks like it's rotating again. Now, one note about using the procedure here, the method here, is I don't have access to the event. So I can't have something happen on the finish animate, on the finish event. So there's that. I'm going to change that. It was a little slow for my taste. 2. Okay. That's it. A little setup here, constructor code in the create. That's it. All there is to it. Oh, I can show you the other one, second form. In here, so all we have is the rectangle click. We have the start the animation. So here's the T path, and it has a data property. I'll come in here. And so this, if you open up an SVG file, which there's the path to it right there, then you'll see there's lots of XML. And in one spot in there, you'll see, I think it's a D element, has all this data that starts out like this and just goes along. And you just copy that data out and paste it into here. And this is the path data. So you can get this path data from an SVG. You can make the path data using a tool like Inkscape, which is a free vector animation tool, or you can just write this manually. The preview shows up as soon as you lose focus from the edit box. So what I'll usually do is click OK and hold it for a second, and you'll see the preview shows up. And then that's how you know it worked. This guy here has the rectangle has a path animation on it, and it has a path data. Here, exact same data, and it's going to just animate that when it's activated. So it takes 30 seconds, it loops, so it's going to keep running through that path forever. And that's all there is to it. Pretty cool, pretty powerful, really, what you can do with that, with just that path data. This sample shows off some of the effects. Go ahead and run it. First of all, we have a smooth magnify here, which I think it looks so cool. Very configurable what you can do with this one. And it just follows my mouse around. Now, it doesn't have to follow the mouse. It's just I told it to follow the mouse, but you could have it offset instead. The difference between the smooth magnify and the regular magnify is the regular magnify has a hard edge, whereas this one has a soft edge. So it looks like a raindrop running across the beach. I don't know. That's not a good example. Anyway, you see what it looks like right there. The cool thing is, see how it's set up? It's actually magnifying these controls as well as the image. Very cool. I'll show you how we do that here in a second. And notice the checkbox here is not being magnified. It's because I uncheck it, it turns off the magnification. Now you'll notice this switch here has hot and a shadow. So when I move over it, it turns hot, which I said purple was the hot color, which is an outer glow. So I love the fact that it understands the shape of the switch. So you see the shadow and the hot follows the coloration, or not the coloration, the lines and stuff that make up the switch. So that's really cool. And here's a checkbox. It doesn't do anything except you check it and uncheck it. But it has a shadow, and again, you notice the shadow actually follows the text. It's not just a blank shadow that, consistent shadow that across. It understands what it's creating the shadow for. So let's look at the code. There's not really a lot of code on this. It's all about the effects being applied to it. So switch box here, here's the glow effect. The glow effect trigger is on mouse over, and then it has a shadow effect that's always enabled. That's it. That's all there is to do those. So if you want to have hot controls, all you do is add a glow effect, and you can change the color if you want to. And you can enable it and see what it looks like at design time. But I'm just having it enabled on mouse over. One note about mouse over is, while this works on mobile there is typically not a concept of a mouse. There is exceptions to that. For example, on Android, you can attach a mouse. But so you probably wouldn't use is mouse over if you wanted to do it on mobile. checkbox, again, all it has is the shadow effect on it. Now for the smooth magnify, here he is here. What I have is I have a layout that fills the form, and all the controls are on that layout. Okay, and so the smooth magnify effect is applied to that layout. Now, if you don't do it that way, if you put the smooth magnify on the form itself, you notice it goes away. So if you want to animate everything on the form, you have to put it all on a layout. Just the way it works. So no big deal. There it is. Now also, in order to capture the mouse cursor movement, I have another layout here that right now is currently set to visible as false. But then on run in the constructor, right here, we set the visibility to true. And so that layout captures my mouse movement, and it has hit test set to true. And the reason I do that is because the layout here, the one that everything is sitting on, that has the smooth magnify on it, it'll give me the mouse move cursor events, but not when the mouse moves over the image or the other controls here. So I could put mouse move events here and then translate those from local to absolute, but the easier way, and also the way I decided to do it, was to put the layout over it. And so the layout's over it when the layout is visible as true. Now the layout doesn't have any filling to it, so it's not, when it's visible, you can't actually see it, just it is there, and it's blocking the mouse movement so that it captures all those events. And then here's the mouse move event. All it does is set the smooth magnify effect center to the point of the mouse move event. That's it. All the code we had to write to do that very cool smooth magnify event. So I wanted to show off some transition effects here. And so what I have on here is a transition effect that's the rotate crumple transition effect. So the transition effects have a target bitmap. And so what we've gone on here is a tab control with 2 tab items on it. And the target bitmap is going to be the screenshot of the second tab item. So this is going to give me a transition between the 2 tab items. Now we do have an action that you can use to do the slide tab transition, but there's a lot more transition effects than that. So let's take a look at how you do that with the different transition effects. So I'm going to run this. First of all, I'm going to point out that this is animated. Okay. Now watch, when I hit switch, it's going to do the transition between the two. Now normally you're going to have something on the screen that you're going to work through, like a wizard, a next button or something like that is going to cause the switch to take effect. But here I just have a button that does switch. And watch, see that? The animation continued. So we'll switch back. See that? The animation still continues even while the transition is taking effect. So I can come in here. And it all is still there. So cool. Anyway, let's show you how this works. You can do this with any transition effect. The swipe one has different behavior. You can do it with the swipe. Actually, the next demo shows you the swipe. But all the rest of transition effects, I think, are going to work almost exactly the same. So in here, first of all, some transition effects have a random seed. This one does. If it doesn't have a random seed, then you can just ignore that line. What I do is I disable the transition effect. Then I set a parent of the transition effect to the active tab. And the reason I do that is I only have one transition effect. So the other tab doesn't have a transition effect on it. So this transition effect jumps from tab to tab. Oops, I scrolled someplace. There we go. Enable the transition effect and start the float animation. So the float animation is on the transition effect, and it targets the progress. So the transition effect, and like I said, most all of them except this swipe one has a progress on it. And all it's going to do is animate that progress, the value of progress from 0% to 100%. That's it. It has a onProcess event. In the onProcess event, what we're going to do is this is where I grab the screenshot of the tab we're moving to. So for on tab item 1, then we get a screenshot of tab item 2. And I grab that screenshot and then I assign it to transition effect 1's target and then free that. So you got to make sure you clean that up if you don't, on at least Windows and OS 10, so that you don't link bitmaps. And then the reverse, if we're on tab item 2, then we just get tab item 1's screenshot. And when it finishes, that is when we actually change the tab. So it's not actually, the tab's not actually changed until the animation finishes, then the tab changes and the user's on the new tab. That's it. That's all there. Oh wait, one thing here, last in the show. This is where I set the random seed. But also, until a tab has been visible, the bitmap's not fully rendered. So if you do this and the bitmap doesn't look right that you're moving towards when you do that make screenshot, do this here. And so what this does is it just changes the active tabs to tab item 2 and then back to tab item 1. That way both of them have been visible, and then it's able to grab a screenshot effectively. If you don't, actually, I'll just show you what this looks like. I'm not sure if this is a bug or not. I think it's just an optimization that it does so that it doesn't have that full screenshot in the background. See how the size is wrong? And then it drops back right. But see, once I've done that, once that tab's been visible, it works correctly. And so just simply here in the form show, you do this. This causes both those tabs to get fully rendered. And then you can use the make screenshot to do the transitions. During the Delphi skill sprint, I mentioned the swipe transition effect. And someone said, oh, could you do a page turn effect? Because that's kind of what it is. And I'm like, I think so. So that's what I've built here. This is the C++ version of it. And what it has is there's 2 memos you see here, and each memo is full of text, in this case, Lorem Ipsum. And I include the page number here so you can see what page we're on. It should be on this one as well. Make it bigger. There it is, page 2. So random text with the page number in it. Now, right now it only turns this way. I implemented the return back, but just come over here, grab the page, and turn it over. Now notice, you see there it says page 3 on the back, and then page 4 is the page I'm going to. So really nice page curl. I let go. It finishes the turn, and I can do this again. All I have to do is move it over a third of the way, or a quarter of the way, and it'll know I'm going to turn the page. If I move less than a quarter of the way, it turns back. That's it. If I move off, it finishes it for me as well. Really cool. Had a lot of fun with this one. So let's take a look at this. This one here has a lot of code, not really that much code, but it has code and layout elements to it. So what we have is, what we see right now is there's this visible layout, and it has 2 memos on it, memo 1 and memo 2. The visible layout also has another layout over the top of it, which I call layout glass. And that does 2 things. First of all, that captures all the mouse movement, whether it's over memo 1 or memo 2. And it prevents the user from, when they're dragging, when the mouse is moving with the cursor down, then the memo is like, oh, you're selecting text. And all of a sudden text gets selected. And I didn't like that. So I could have probably hid selection or something like that on the memo to prevent that from happening. But I needed to capture all the mouse movement as well. So I just put a layout over the top. Now, what you could do is you could look at the mouse movement with like a gesture and say, oh, is it from the edge and moving in? All right, they're turning the page, and you could invoke different behavior, make the layout visible. If it's somewhere in the middle of the form, then you could have different behavior. You could let them select text, stuff like that. So there's certainly some pre-processing you could do to change that behavior. So the swipe effect is on the visible layout, which has the memo on it. And we also have this thing here, the swipe point. And what this does is this finishes with the swipe animation, which is a path animation, finishes the page turn. So if the user lets go anywhere in the process, then it finishes it off. And that's what that purpose is there. Now, there's another layout that you can't see because it's underneath this that I call the layout virtual. And it also has 2 memos on it, memo 3, memo 4. Memo 3 is here, memo 4 is there. And those are used for the screenshot purposes. You actually never see those, but they're laid out on this virtual layout, and then I do make screenshot on the layout virtual in order to get a layout of what the page the user is turning to looks like and what the back of this page looks like. So actually, the swipe effect has 2 bitmaps on it, has a target and a back. These are actually both the same bitmap, but the back bitmap is flipped horizontally in order for it to show up correctly. If you take that out, you'll see that it's backwards because it's on the back side of the image. Okay, so let's show you some of the code here. I probably won't go through all of it. Let's see. So here, this is the finishes the turn. So when they let go with the mouse or move the mouse off of it, this is where it finishes the turn. This is we're using the swipe animation. So we set the swipe point up and then set a path. We look to see if the mouse is, if they've moved more than half the distance or a quarter of the distance. If they have, then we have them, the path take the animation all the way to the end. Otherwise, we have the path animation take it back to the full client width in the upper right-hand corner. Okay, and we start the animation. If you were going to let them swipe from both corners, so like I said, right now, right, it only makes sense to swipe from this corner, you would just have to look at the mouse and move the mouse cursor, which is the corner. Let's see, I do that in the constructor here. Right here, corner point and mouse point, those are right now set to the upper right-hand corner. You would just change these to the lower right-hand corner if they have their mouse down there when they start the movement, and then you get the behavior you want that way. So when the mouse, when they tap, when the mouse goes down, that's when we're going to go in here and we're going to grab the screenshot. Okay, so we grab the screenshot and we set the mouse point to wherever the point they put the mouse down on. And so the mouse point is the point of the corner. That's the corner of the page is in the page curl is set to the mouse point. So we go through and grab the screenshots. Same screenshot, we apply the first one to the target, flip it horizontally and apply it to the background. And we also bring the layout virtual. So you bring to front and that renders that. Remember we talked about that. You have to have it visible before it gets rendered. So we just bring it to front, render it, and then push it back to the back again. Here we go. As the mouse is moving across the layout glass, the glass is the clear one in front you can't see. All we do is set the mouse point of the swipe transition to the current mouse position. If the mouse leaves or the user lets go with the mouse up, then we do finish turn. You know, I didn't test this on a mobile device. Mobile device, you might want to do this with interactive gesture instead of the mouse movement. It might work. I should have tested that. I know the transitions work, but whether or not this code, because it looks at mouse instead of touch points, might be different. And then here's the finish. All the finish does is it fills the memo with the new text and disables the animation. That's really all it does. It looks to see if we actually completed the page turn or not. If we did, then we move the pages that were in memo 3 to memo 1, and memo 4 to memo 2, and then get the next two pages. There we go. That's all there is to it. Oh, the swipe animation, there actually is a live binding in here. Bind visually between, that's for the lorem ipsum. Yeah, so the lorem ipsum again from the prototype bind source. I thought I had live bound someplace else. I guess I didn't do that. But the swipe animation, when it processes, so this is what finishes the page turn, then it takes the swipe point position. So the swipe point is what's animated, is the swipe point, and it takes its position and puts it in the mouse point. And that's how, now you can't actually see the swipe point, otherwise it'd be a little circle. You can see the circle on the screen, but it's what's animated, and then that animation is then applied to the mouse point, and that's what gives you that smooth finish. So, and it's a little slower than it probably would be as far as the finish animation, just because it's easier to see here. But then if you're going to do this in production, you might speed that up so that it's faster. And then because user likes to see the mouse, the animation, but they don't want to take any of their time. They want to get back to reading. So anyway, there goes a page turn sample for you. For more information, you can check out the links here. Some of these I mentioned earlier. Also, there's the fantastic Code Rage session from, I think it was Code Rage 8 by Robert Love, which is the VCL Developer's Guide to FireMonkey. And it goes through a lot of the nuances of FireMonkey to really get you more familiar with how FireMonkey works and some of the different ways of thinking with FireMonkey. And it comes from the idea that you have a background in VCL development. The shader filter sample we ship, it's available right there, and which I showed you that, and it shows applying all of the different effects to the image there. But if you want to download the example code I have, you can check that out there at the blog notes link, which is embt.co/sprint-effects. Give me a brief moment to tell you about this limited time special offer. All 10 Seattle registered users get the bonus pack, which includes the new Object Pascal Handbook by Marco Cantu. This essential language reference is a modern language guide that includes new features of the language and the core runtime library, a must-have for any Delphi developer. Also get the Binder Converter Basic. It handles the heavy lifting when converting existing VCL applications into FireMonkey applications, so you can start taking advantage of multi-device development right away. And the Premium Style Pack includes premium styles for VCL and FireMonkey to make your application look great on every platform. For more information on these special offers, or to find out what the current offers are, please visit www.embarcadero.com/radoffer. And one more special offer we have only for the month of February is if you buy one tool, you get another tool for free. And it's a tool of equal or lesser price. The website says value, but sometimes you feel like you're getting better value out of the free tool. It feels like sometimes, at least for me. So if you buy Rad Studio, Delphi, or C++ Builder 10 Seattle, either new user or upgrade, Professional Enterprise Ultimate Architect, you can get any of those tools you see there. For example, Kanopka Signature VCL controls, CodeSite Studio 5, Interbase, or a number of the other database tools. Full details and instructions are available at the Rad offer page you see down there at the bottom. So check that out. If you don't have 10 Seattle yet, this is a great time to upgrade to 10 Seattle and take advantage of the special offer. Next time, we have effective if-def usage for cross-platform development and conditional compilation. The Tuesday skill sprint for Delphi is on the 16th of February, and the C++ skill sprint is on Thursday, which is the 18th of February. Check out the full schedule there, and always verify your time and dates are correct, because we base it on San Francisco. Sometimes daylight savings time changes in unexpected ways, so make sure you show up at the right time. And now it's time for Q&A. As I pointed out, the page turn sample was based on a question that came up in the Object Pascal track, because whether or not you could do that. And there's some things that you could do to improve that. It's probably not completely robust yet. Like, for example, it only handles the upper right-hand corner. It doesn't have the turn backwards and stuff like that. But you get the basic idea of all of what's involved in that, and then you can expand it to deal with the other situations. Are there any animations in VCL? There are not animation components per se in VCL, but there are things that do have animations, and you could add animations. So I showed you in here the animation effects and the animation components and stuff like that, and procedures. There's not a VCL equivalent to that. Now, one of the reasons that FireMonkey has animations where VCL doesn't is FireMonkey is based on runs on all the graphics run on the GPU and DirectX and OpenGL. And so those libraries and the GPU really make it easy to deal with animations and effects and stuff like that. So this is just really exposing some of the functionality of the fact that it's built on that. Now, I'm going to look real quick and see on the VCL side if there are. There's a T-Animate component in VCL that you can look at. It's in Unit VCL COM controls. That's the only component that's related to animation available on the VCL side, though, that I'm aware of offhand. If you do have the Kanopka Signature VCL controls, then there's the TRZ Animator as well, which you could check out. Okay, well, hopefully we'll see you all next week when we talk about the effective if-def usage for cross-platform compilation and conditional compilation. Should be some useful stuff in there as you're trying to address all the different platforms. So hope to see you then. So tell your friends to join us on Tuesday for Delphi skill sprints and Thursday for C++ skill sprints. You're welcome, Roger. Glad you enjoyed this. I think it's really cool stuff what you can do here. And like I said, it's not so much about making the user interface crazy and overly busy, but just to give it a little bit more life and make it a little bit more intuitive to the user through the way it all works. So glad you enjoyed this, and we will see you all next week. Bye.